Where are we at now? If you could give a snapshot in time of what's currently possible versus what you think will be possible in the next 10 years.
Right now, I think the thing that we're trying to figure out and we're most interested in and putting a lot of effort into is being able to do a large number of gene edits on an organism at the same time in order to change its genetics so that we can create whatever we want. There are a lot of bottlenecks and things there, but I think we have a pretty good grasp and we're making a lot of progress forward on that stuff. Just to do like massive numbers of edits and massive numbers of embryos to understand how everything works, we could basically sculpt life.
I think in layman's terms, it's really about cracking the code of life. It's such a big amount of code to crack. Like there's 3 billion nucleotides in a human, and then there's also different animals with different codes of life. And it's all about data at the end of the day. It's all about drawing correlations between what you get in real life, like the phenotype, and the genotype, like the genes that contribute to, let's say, black hair or intelligence or whatever it is that we're looking for from an outsider's perspective. It's getting the code that correlates with that. That part is really challenging and is one that requires a massive amount of testing, data, experimentation, and the reason why we're focused on creating a really streamlined platform that does a lot of gene edits at the same time is so we can gather that data as much as possible, and ultimately with more data in 10 years time, as you can imagine, when you crack a code, you can basically build anything you want with the building blocks of what you understand.